Hi there, this is Anshula Sava. Today I am going to showcase my weekend project that I did. I am calling it envvc, Environment Version Control. So this version control is for the reinforcement learning environments. So let me tell you brief about it. So reinforcement learning agents learn inside environments. An environment is really just a folder, some config, some code, and usually a few very large files, a train model or a reply buffer, often gigabytes each. Those folders change constantly, and increasingly it's AI agents doing the changing, not people. So you want the things version controls give you: a history, branches, the ability to fork one and try something without breaking the original. So the obvious answer is GitHub, and it's the wrong shape for this in three specific ways. Git wants you to download the whole thing before you can look at it. A fork is a full copy, so 1,000 experiments mean 1,000 copies of the same gigabytes, and it assumes a human is watching when two changes collide. So I built version control where the unit is the environment, not the repository. There's one shared pool of content for everything on the server. A fork is a pointer into it, not a copy. You can check out a 2 GB environment without downloading it, and when two agents write at the same time, nobody has to be watching. Let me show you. So before we start, on the right I am taking an event log. It's sending in for build service, one line every time anything on the server changes, and it's how a CI system would know to kick off a run. Watch it while I work. So first, I will log our commits. So this is our environment. Now let me clone it. So you see, that's 2.2 GB of environment checked out in 15 milliseconds. Let me list out what is there. And it put only 220 kilobytes on the disk. The config and the source came down because they are small. The checkpoints and the replay buffer didn't. Let's fork this repo. So it took around 22 milliseconds and 0 bytes copied, and the fork's head hash is byte identical to the parents. A fork is one row in a database, a name, and a pointer into the shared store. It's O1 whether the environment is 2 GB or 2 TB. Now let me edit a huge large file with that. So what I'm doing is I'm taking any 1 MB of chunk in the file in the data slash replay.bin, and I'm feeding it with some random seed. Okay, and let me commit it. Okay, so we have committed our change. If you see, I rewrote a 1 megabyte in the middle of a 256 megabyte file, and you see it shipped only 4 chunks, about around 1% of the whole file. Files are split into content defined boundaries. So inserting byte in the middle shifts the boundaries with the content instead of misaligning everything after it. Git would store a whole new 256 blob. Now let me show you how did you fork it here. I'll create a new environment. Let's name it other team in the other directory, and I'll copy one of the file, let's say this repo.bin, in our new environment, and let's see. Okay, I'll just add a readme.md and I'll just commit it. Okay. Unlimited team commit, but it's good. I think I used the wrong flag here. Let me change the small c to capital C. Okay, now you see there is an event for commit in the right, and you can also see that there are, like, now we have two different environments. They might be for two different teams and different file name also, and there is no shared history at all. And it uploaded at 34 bytes for this. The 34 bytes is that's the readme, and the 256 megabytes were already in the store, so they weren't synced. That's one global content address store. dedupe across forks and across unrelated projects isn't a feature anyone implemented. It's a consequence of addressing content by its hash. Let's see. Now I'll show you a race condition. I need to rename the directory for this. Desktop. So you see, I started 4 agents and they committed to the same reference at the same instant. One wins, the other 3 gets the exit code 3, its own exit code. So a script can branch on it and a message that says nothing was lost and why won't retry for them. Okay, let me see a cherry kick and see how cherry picks work. Okay, so what I'm doing is, I show you. I'm making a change to reward.py file. So I made a commit to our system, and let me get the commit hash of this in the fix variable, and let me cherry pick this. See, cherry pick. Okay, so what I'm doing is I'm cherry picking the last commit, and if you see, I refer to the reward.py and then I'll show the config again. Okay. You fork an environment 1,000 times, then find a bug in the original. This propagates one fix into a fork that has moved on in 7 milliseconds across a 2 GB environment because it only touches the parts the fix touched. If both sides had edited the same lines, it refuses by name and writes nothing, rather than leaving conflict markers in a file that some agent will be happy to commit. Okay, let's see how authorization works here. Let's try to read from a read-only token into a config canvas. Yeah, we should be able to read it. Now let's try to branch from a read-only token. It should ideally should not let us allow it. Yeah, the branch was refused. Now let's try to maybe fork or from our read-only token. We can also try doing curl to our system to read logs and see if it is allowed or not. Let's start with our AN ID and see the address was not found. Now let's start with our fake ID. If we have fake ID here in our system as an environment variable. See, the address was not found. So basically there are no users, no roles, no passwords, just token carrying an explicit list of environments/operations that are granted. This one is read only on one environment. It reads what it was granted and it's refused a write and a fork separately. The operation don't imply each other, and an environment it can't see answers for bytes identically to one that has never existed. Same status, same body, same length. If those differed, you would have an oracle for probing what other tenants have. Okay. So last, let me show you. So everything that I just showed you by hand is also a self-verifying test. Each claim has a machine-checked criteria and the program exits non-zero if any of them stop holding. The claim is my design dog aren't assertions, they are assumptions with a test attached. Thank you so much. I hope you like the experiment. I did.